Oh boy. All right, so we're talking, is the function even, odd, or neither? So symmetry, there were a couple options for us with symmetry. We could have y-axis symmetry, we could have x-axis symmetry, we could have origin symmetry. Now we're going to talk about if the function is considered even or odd, which goes right along with symmetry. Before we had 3 options, now we only have 2. But we had talked about that functions couldn't have x-axis symmetry because then it automatically wasn't a function because it would fail the vertical line test. So we're going to only look at 2 specific types of symmetry that go along with functions. So an even function is something that's symmetric over the y-axis. So our most basic even function is our x squared.
Mr. Cosman, please contact the main office. Mr. Cosman.
X squared is our most basic even function. So we want it to be symmetric over the y-axis in order for it to be considered even. Another kind of quick little shortcut we can take is if we look at the equation and every single exponent in the equation is even, then it's an even function. So all the exponents are even, and we can have constants. So a constant would have an exponent of 0 because there aren't any x's in it. So we consider our constants to be classified with our even functions. A constant, remember, is just a plain old number. And the reason we can have constants and even functions is all our constant is going to do is move it up and down, right? That's the number we add or subtract at the end. So if I move the function up or down, it's still going to be symmetric over the y-axis. So here, constants are okay. An odd function is going to be symmetric over the origin, which kind of makes it nice to remember. Odd and origin, the O's go together. So this is symmetric over origin. Our most basic odd function is just our linear function, x. Our odd functions are going to have all odd exponents. So all the exponents are odd, and in this situation, a constant is not okay because if you move the graph up or you move the graph down, it's no longer going to be symmetric over the origin. So we cannot have constants. Any function that isn't even or isn't odd would be considered neither. So those are going to be our functions that are not symmetric. Not symmetric. And we have lots of options here for different functions. It might be something like if I move my parabola over, it's no longer symmetric. This would be something like x minus 2 squared. So we're going to end up having a combination of even and odd exponents. Or it might be something that has an odd exponent and a constant, because constants are considered even. It's gonna, anytime it's not all even or all odd, we'll say it's neither, because it doesn't fall into either category. So you're gonna look at graphs today and decide if they're even or odd, or neither, and you're also gonna look at equations. So let's look at a couple examples, and then we'll get rocking and rolling. So if I give you graphs and say determine if the graph is even, odd, or neither, we want to know, is it symmetric over the y-axis, symmetric over the origin, or it's not symmetric at all. So if I look at A is my best replica of the cosine graph. Is it even, odd, or neither? It's even, right? It's even. I might also make a note that this is y equals cosine of x. Since cosine doesn't have any exponents, in case you see a cosine equation, you'll know that cosine is an even function. What about B? Neither, right? Neither. Because it moved up, it's not perfectly reflecting over the origin. It's not centered at the origin, so it can't be reflected over the origin. I also know that that's a linear equation, right? That moved up 1. So if I was going to write that equation, it would be y equals x plus 1. And there I have a variable with an odd exponent, right? The exponent's not there, it's 1. And it has a constant, so it's got a combo of odd and constant. So that's no good. What about C? Odd. What graph is that? A sine graph. Yes. Ah, sine is odd. These parent functions will follow you forever and ever and ever and ever, or at least until June when you move on to your next math class. What about D? Odd. That's a cubic function. So then I could also give you, don't both? I'm just so excited. The next ones I'm going to give you the equations. I'm going to ask you to determine if the equation is even, odd, or neither. First one I'm going to give you is y equals x to the 4th plus 3x squared plus 1. So I don't care about the coefficients. I only care about my exponents and my constants. So I want to look and say, okay, I've got a 4, a 2, and a constant. 4 is even. 2 is even, and a constant is considered even. Even though it's a 1, I don't care what the number is, I just care that it's a constant. So it's considered even. So because everything in there is considered even, that makes this an even function. If they're not all even, or they're not all odd, then it's neither. So if I look at the next one, I've got a constant and an exponent. My exponent here, even though it's not written, is really a 1. 1 is odd, so my exponent is odd. And a constant counts as even. So I've got a combo going on here, so neither. What about C?
You said constants are always even?
Constants are always even, because our constants are moving up and down, right? That's our vertical translation. So they only count as even. No matter what the actual number is, they're only even. You could also think about it as it's really like saying x to the 0, because there's no x's there anytime you have a constant. And even though 0 isn't even or odd, we're going to keep it in the 0 and the even category for this. C is odd, right? Because I have a 3 and a 1. 3 and 1 are both odd. 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 So since the whole thing is odd, I can say that this is an odd function. What about D? Y equals x squared times the quantity of x cubed minus x 4x. It's what? We're going even? You're locking it in?
He knows it's even.
I mean, and he's an adult now, so he knows. He just knows. Why is it even? Because I had 3 choices to choose from, and that one felt right.
Because there's 2 data. Is it odd? It's neither.
Ah, interesting.
I was
gonna ask.
Ooh, I heard a magic word. Do we have to distribute? Yes. Yes. So I can't look at that right now and say, okay, I even though I have a 2, a 3, and a 1, I don't really know what's happening there until I actually distribute. So if there's things I have to do to simplify first, I have to simplify it before I can decide. So if I distribute this, dusting off your exponent rules, what happens when I distribute it? X squared times x to the third minus 4. That's what we're saying? Wait a second.
Don't you add the
Aha, there we go.
So
So it's
it's 5.
5.
So it's odd.
So it's 5 and 3, because when we're multiplying, we add the exponents. So this is odd. Just in case you ever need your exponent rules again, if you're in here, they're up on the wall. If you're at home, they're linked on the very first page of your virtual classroom.
You can leave those up for
On your virtual classroom, wait, or on the wall, that second group, all that like 9 right there, in front of them, they're all right there. Am I gonna leave that up for? Yeah. I'll leave it. Except for like SATs and PARC, because I'm actually not allowed to. But Well, there you go.